cats and rabbits who reside in and get dressed in shoes and hats and trousers. In a world of my own, all the flowers. I wouldn't be here. There's just trouble with me. I give myself very good advice, but I very seldom follow it. That explains the trouble that I'm always in. Be patient is very good advice. Cats and rabbits who reside in and get dressed in shoes and hats and trousers. In a world of my own, all the flowers.
Of course, he's mad too.
But I don't want to go among mad people.
Oh, you can't help that. Most everyone's mad here.
Welcome everybody. This is our stream series, Sunny in Wonderland. If you guys haven't tuned in before, you're missing out. Tonight, we have Dr. Sunny giving part 2 of her HTTP request smuggling workshop that she's running. If you guys have been following along, you know what's going on here, and you obviously know who Dr. Sunny is, and she does amazing work. She's a brilliant mentor and teacher, and you guys will definitely learn something tonight. If you guys need something or you have questions, feel free to drop them in YouTube or in Discord and let us know. We'll get them shuttled to Dr. Sunny. With that, I'm not going to eat up her time. Y'all are here to listen to her talk anyway and not me. So, Chris, take it away.
Hello, everyone. Welcome. Welcome to part 2 of our series on HTTP request smuggling. Thank you for joining tonight. I wanted to just point out that if you missed part 1, the link to the recording is available. It's also on our YouTube channel. So tonight, as we go into part 2, we're going to just pick up right where we left off, which was on lab 2. Depending upon how much progress we make tonight, depends on whether we'll have a part 3. I don't want to rush any of this. I want to make sure that people understand the concept. So we'll just play it by ear tonight and see how it goes. Once again, the talk is sponsored by the Neon Temple, and we are a cybersecurity guild. And find out more about us, follow us on YouTube, or check out our website. So just a real quick recap. Part 1, we level set on what is HTTP request smuggling, and we talked about the 2 different ways that requests can be sent and how they end, and how a web. We also did lab 1 together. So what we're going to do tonight is we're going to look at detection techniques and also confirmations that what you're looking at is indeed HTTP request smuggling. And we will try to do labs 2 through 6, maybe even more if we have time. So I'm going to go ahead and get us to the point where we left off. So lab 1 was just a counting lab where I showed you how you can use burp to help you count. That would be the length of the post bodies. Detection techniques, basically in review, we talked about the 2 types, using content length or transfer encoding. Remember that you'll always try the content length technique first, because when you try the transfer encoding, you are going to be poisoning the response queue. And we'll talk more about that later. So I'm just going to fast forward to, so this was the lab that we stopped with. This is the basic content length transfer encoding vulnerability lab. And so what we're going to start on tonight is the lab number 3, which is our TE, or transfer encoding content length vulnerability lab. So what you'll want to do is go ahead, and I'm going to stop sharing there, and I'm going to share my burp. Here we go. So what we're going to do is this is the one we did last week, or I'm sorry, last month. So this is the one you'll want to crank up for right now. This is a pretty simple, basic style. It's really just to introduce the concept of sending transactions using the TE technique. So what I do is when I start the labs, I start them in a new tab. It's just convenient for me so that I can then copy this URL. And I think what we'll do is we'll just do this one together, just so that everybody kind of gets back into the mode of doing these. So what I do is I like to put I use the built-in browser, by the way, inside of Burp, just because it's very convenient. So what we want to do is we want to set our proxy history so that we can see all of the traffic coming in. And you can see that just hitting this main site here, I can see the GET request. So really the easiest way to do this is to go ahead and send this GET to repeater. Now remember, we want to make sure that you are not automatically updating the content length. And let me just turn this off. We want to make sure that this is unchecked. And that is because as we do these techniques, we want to be in control of the content length amount so that we can perform the attacks. So make sure that this is unchecked. So the first thing that we have to do is we need to convert our GET to a post. Well, this is really easy inside of Burp. You just right click and you can change the request method. So now we have a post. And then if you look at the instructions inside of the solution, it's going to give you everything else that you need. So we already have this, and the host is specific to our lab. So we're just going to grab the rest of this. And you really don't need any of these other headers. So let's talk about what we're looking at here. Remember, this is TE. So TE, or transfer encoding, tells the device, okay, I want you to go out this many bytes. This is the hexadecimal representation. And I want you to read everything all the way to the terminating 0. And that's going to be all of the message. Now, in this case, of course, we are smuggling in, we're basically smuggling in everything. And then the back end is only going to read 4 bytes, which means it's just going to read up to, let's just double check this. So it's only going to read some of the request. And as we talked about last time, when only partial requests are sent to the backend because they're being smuggled in, they will be held there, and then they will be concatenated with the very next request that gets sent to the web server. So in this case, when we send this the first time, we should get a response that we should expect, but then the second time, we're going to get a response that is to this G post, which is basically a non-existent verb. So we send it the first time, we get our 200. We send it the second time, and that's when we get this message that says, well, I don't understand what G post is. We take a look at our slides. Let me just... If we take a look at our slides, you can see that we have smuggled in the latter part of this using the TE technique with our terminating 0. But on the back end, there were 15 bytes that were read. So it did not have a complete request when it got the G. So it concatenated that G with the next request, which was another post. And so that is why we received the message unrecognized G post. So I wouldn't actually consider these rudimentary examples here to be able for you to use as detection methods. This is really just to get your feet wet in understanding what can be done and how the two techniques work. As we go, we'll see some better examples because in a lot of cases, the servers on the back end are not going to like that you don't have a host header here. And that's when you start getting into having to send bigger requests over so that you can have hosts from previous requests concatenated with your prefix. So it can get a little confusing. I think there might be a question. So let me put this over here. Any questions so far? Okay, not yet. All right. Okay, so that was just sort of get you used to that. Now, if you guys want me to pause to give you guys time to do each lab, I can do it that way as well, or we can do them together. So you guys let me know what you like. I'm going to just go through the slides like this because it's a little bit easier for me instead of having to shift back and forth. So the next topic is sometimes you will have a WAF that stands in front of you performing your HTTP request smuggling. And so there are some evasion techniques that you can do in order to try to get the transfer encoding to be read on the backend web server. And how this has been done in the past is by taking the header transfer encoding, but then doing something a little bit different with it. So in this case, you see there's an X in front of the word chunked. Here you can see there's a space right after the transfer encoding, right? But before the colon. Here there's been tabs have been used. I've actually seen this technique work in real life. And so on. So you can kind of get an idea here. So once again, the whole idea is you're still performing the CLTE or the TECL. It's just that there's some sort of WAF or there's some sort of mitigation that might be in place. And so this is an evasion technique. So lab 4 is really about you doing this yourself. Using an evasion technique to then have the request smuggled to the back end. So if you guys like, we can do this together. And I guess, guys, just let me know if you hear which way people would like to do this, but I don't mind doing it on stream with everyone.
I'd say let's roll it that way, Sunny. Everyone liked it that way last time, so.
Okay, so you want me to just go ahead and do each lab, and then if there's any questions, you guys just speak up.
Yes, ma'am. Yeah, they're saying they'd like to see you guide them through it on YouTube.
Okay, great. Okay, so once again, I'm going to open my browser. So if we take a look at the lab solution itself, make sure that you don't have that update content. And I'm just going to start out. I go to my HTTP history. I'm going to look for that get against the document root. I'm going to send that to repeater. I'm going to change the get to a post. I'm going to get rid of all of this stuff because I don't need it. And then just copy, basically starting here at this content type all the way down. Now, one of the things that I do is I like to leave a couple of spaces here. It shouldn't affect it, but sometimes the labs can be a little bit quirky, so that seems to work better. But once again, what we're doing here is usually they'll tell us too what the devices read. So it says this lab involves a front end and back end server. The two servers handle duplicate request headers in different ways. The front end rejects the requests that aren't using get or post. So to solve it, smuggle a request to the backend so that the next request processed by the backend server appears to use the method gpost. So the obfuscation, which is just a fancy word for trying to hide something, but not very well. The obfuscation here, or the evasion technique that we're using, is this second transfer encoding header that says cow. So we've got this one, and then we've got this one. And I would imagine that it doesn't know what cow is, but it probably picks up this one. So this is like a, make a big noise over here and don't look at what's going on here. So if we send this the first time, we get our 200, we get a nice response. But once again, this little G kind of hangs out there and then gets concatenated with the next request we send. So when we click send again, that's when we're going to get our unrecognized method of gpost. So that is evasion. And something that is pretty cool here. Let me just show you this real fast. This is just to give you an idea of what's been done in real life with this particular technique. So $7,000 bug bounty was paid out for this. So in this particular attack, we have a smuggled request, and to get things through the WAF, the transfer encoding used a tab in front of the word chunked. So they were able to then, and this was James Kettle, he was able to then smuggle his put request. And this put request, basically he flooded, so this is something we've not covered yet, but you can flood and almost create like a buffer overflow in the back end for purposes of having your arbitrary prefix concatenated to somebody else's request. And when that was done, he was able to see somebody else's request. And you might think, well, what's the big deal? Why would he get $7,000 for that? Well, because if you can see enough of somebody's request, you can obviously see their cookie, you can see their token, you can see sensitive information. So this is sort of just to kind of give you a little tease. This is where all of this is going. You might think right now, well, why is she showing us all these mechanics and everything? Well, it's to get you here. But if I jump right here immediately, you guys, I might lose you. So that's why we're going through what we are. All right, so that was lab 4. All right, let's talk about confirmation. So what is it that you can do when you start doing these requests to help you feel better that you actually have something? Well, if you're performing the CLTE, and remember, we can use just the letters. So CL is content length, TE is transfer encoding. So if you were performing a CLTE, and in this, you've got a content length of 51 bytes. So that would take you all the way to this X here. So you're trying to smuggle in everything that's in blue and everything that's in orange. And then your next request would be another post. This is assuming there aren't other users on the system. What you're hoping is that the backend parses this into 3 responses so that when you send this second request of the post, you actually get a 404 because it's responding to this get. Chances are it'll just concatenate because this is not a complete request, but the ultimate goal is that you're hoping to confirm that you've poisoned the queue on the back end, and how you can confirm that is by receiving a response of 404. It's going to be the same way if you use the TECL technique, where once again, in your transfer encoding chunked amount of data, it's going to be all the blue and orange. That goes first, and then when you click the send again, this is in repeater like we've been doing, you're hoping to get a 404. And you'll see this pattern repeated in a lot of the labs. So labs 5 and 6 go through this confirmation check where you're trying to confirm that you did the technique properly, and that you are getting a response that you expect. I want to back up 1 second though, and also say that, let's say that your smuggled request isn't /404, which we know doesn't actually exist, which is kind of why it's a confirmation. Let's say instead of that, let's say you do like robots.txt. If you actually get robots.txt in your response, or even in an amalgamated response, where it's embedded within another response, then yeah, you've got smuggling. So I just kind of wanted to throw that out there because those are techniques that I have seen done in real life and have worked.
I've got a question for you, Dr. Sunny.
Great.
Sam is wanting to know, how does that confirmation check work when you may not be the only person currently sending traffic?
Excellent question. And it makes it much more difficult. So the more users you have on the system, the harder it will be to get your confirmation. So it would be great if you had like if you were working on a team of penetration testers and you had like a second penetration tester that could hit the website. And so let's say that you're trying to send them to your website, or even change the website that's being shown on the page. I actually have a slide of this, if you give me just a second. So we haven't gotten to the downgrade attack, but this is kind of where I'm going with this. So let's say that there aren't a lot of users. A lot of times, penetration testers, we get to work in like UAT environments, so there aren't that many users there. But if it is a live production system, you're going to have to either, have something scripted that you can run, or have another teammate that can keep hitting the site. But what you could do is you could send that get and put as the host like some other site or maybe your site. And when that smuggled request gets over, if the other teammate keeps clicking refresh on the targeted site and they see your page, there's your evidence. So I hope that helps. Did that help, Sam? Or anyway, maybe we'll hear back from him. Okay, so let's go ahead and do those labs, and that have to do with the confirmation. So hopefully that helped in that explanation.
He said that explanation helped quite a bit. Thank you.
Okay, great, cool. Yeah, and it's a pretty cool thing to see it actually happen on your victim site. So yeah. All right. So let's keep going. So we are on the HTTP request smuggling, confirming a CLTE vulnerability via differential responses. So we're doing our confirmations. I'm going to open up the lab. And I'm going to open up my browser. Okay, so let's take a look at our, I like to read this part because usually they'll tell us like what the front end server is going to receive, how it's going to receive the HTTP request and how the backend will. So it says this lab involves a front end and back end server. The front end doesn't support chunked, so it's going to be CLTE. To solve the lab, smuggle a request to the back end so that the subsequent request for the root triggers a 404 not found response. Okay. So let's go ahead and grab our root. Let me minimize this. Make sure I get the root. Send that to repeater. Change it to a post. Get rid of all of this. All right, so I'm going to grab all of this. Of course, /404 is a non-existent endpoint, which is what we want. So to know that our request got smuggled through, we're going to send this twice. And we did get a 404, and I didn't minimize my, but there you go. So that is solved on that one using the CL technique. So now we're going to do same thing, but with TE-CL technique. Okay, so same deal. Just go ahead and send this over to repeater. Change the get to a post. Get rid of all of this. go back to the solution and grab all of this, paste it in, send it twice, and there you go. So those are the confirmation labs. All right. So some of you may still be wondering, all right, well, you showed us the basics, you showed us how to count, you showed us the basics, you showed us some confirmation, but what can we really do with this thing? So this next section goes into the different types of attacks that can be done. So we're going to look at bypassing front-end security controls, which could be WAFs, could be other firewall devices that basically prevent us from seeing administrative consoles. So most of the time, admin consoles would only be available internally on the internal or the intranet. And so if we can smuggle requests to the backend, perhaps we can then make calls to try to access those consoles. Another thing that we're going to look at is how we can capture another user's request, which is sort of what I alluded to in that Trillo bug bounty that I just showed you a few minutes ago. So we're going to look at actually how we can perform that attack as well, not against Trello, but in the labs that we're going to do. So the bypassing of the front-end security controls can be done either, of course, through CLTE technique or the TECL technique. So lab 7, we're going to go through this. This is using the CLTE, and then lab 8 will be the TECL. Okay, so let me close this one and this one. So it's going to be this lab right here. Going to open our browser. And let me just make sure I don't have to do any other steps. So it says this lab involves front end and back end. Obviously, the front end doesn't support chunked. There's an admin panel that's available at /admin, but the front end server blocks access to it. So to solve the lab, we're going to smuggle a request to the back end, access that admin panel, and delete the user Carlos. So it says, go ahead and try to visit the /admin and notice that it's blocked. So we can do that. We'll just put that in our browser here. And it says, it's blocked. Okay, no problem. So what we're going to do is we're just going to take our get, send it to repeater. We're going to change our get to a post. And let me just make sure I can get rid of all of this. So what they're showing you here, they have some iterations to go through. But they're trying to just show you that you need to continue to increase the content length in order to provide more information that the web server on the back end is wanting. So in this first request, with the content length of 54, we have to have this local host here. In the next one, we're adding the content type, which isn't there. And in the final one, we've got a content length of 139, and we actually are going to, so basically we've found the admin console, and then we're going to delete. Let's start with this middle one though, so that we can see the console. So what I want to do is I want to search for admin, and I can see here that the second request, my second request of get admin, was smuggled in and has allowed me now to have access to the administrative console. Now it is embedded in this other response, right? So, and remember I had mentioned that. So like, let's say that this is, the robots.txt, but it gets embedded in the response of the other. As long as you can see it, meaning you have true evidence, then it's definitely a finding. So from this point, all we need to do is just add the rest of this. However, before you click send, let's go back to the instructions, because we actually need to increase the size, right? I think we need to increase it to 139. Let me just double check. So yeah, because we've got, this additional information. So let's send that. And I don't want that. So let me make sure that I copied everything properly. Okay, and there we go. So whenever the labs don't seem to work right, always go back to the instructions. So there you can see we got it. So these labs are a little bit, what is the word? Contrived in some ways. They're very good examples of what can be done. But in order to get them solved, sometimes you have to go back to the instructions and make sure that everything is just right. Okay, so I think we've got time for one more, and then we'll stop for this session. So let's go ahead and do lab 8. Lab 8 is exactly the same, just using the TECL technique instead. So let's go ahead and start that one. All right. So we're going to grab our get, send it to repeater, change this, and let's go ahead and, for sake of time, let's just kind of grab this last one here. And there we go. Okay, so so we're going to stop in our slides at this Sunny's burp tip. So this is something that we're going to talk about before we get into the next section of our content. But I'm going to go ahead and stop sharing. And do you guys want me to take us out, or do we have any other questions? We've got like 4 minutes. So
yeah, I'm not seeing any more questions just yet in the channel or on YouTube.
Okay, all right. Well, thank you everybody for attending tonight. Thank you for your attention. Look forward to seeing you next month. Bye-bye.